In section 4, we're going to talk about estimating lines of best fit. So a line of best fit is also known as a regression line. It is specifically used when you're comparing two variables, and it determines the linear equation that best fits the data. So it goes with our scatter plot. So since that was the graph we discussed where you were looking at two variables, kind of determine the linear relationship that exists between those. Along with calculating the line of best fit, you get something called the correlation coefficient. And what it does is it determines the strength and direction of two quantitative variables. So what that means is, depending on what that value is, it can tell you whether or not the relationship that exists between those two variables is a strong one or a weak one. And it can tell you whether or not it's a positive or a negative relationship. And it's represented by the letter R. There is a mathematical formula to calculate R. We're not going to talk about it. We're also not going to talk about how to calculate it mathematically. We're only going to use the calculator to do it for us. So just a couple examples here. So we have some examples of some two variable data. And when you're calculating the line of best fit, you can kind of eyeball it and be like, okay, this is a linear equation that best fits my data. So like the first example here, we have temperature and sales. So what a line of best fit does is it tries to minimize the vertical distance each point is from that line. So it's not necessarily going to go through a lot of the points, but what it is going to try to fit the data as best as possible. So one thing I can tell from here is that I have a positive relationship that exists between temperature and sales. The higher the temperature, the more sales. Now it's really hard to tell R, our correlation coefficient, how strong the relationship is just by the graph. I would say this is a pretty strong relationship just because a lot of the data is pretty linear. Next we have height and weight. So again, kind of drawing the line to kind of best fit that. Not as strong as a relationship here. Without knowing the values here, like we don't know the weight or the height. But this one definitely not as strong as a relationship. Still positive, so it tells you the more you weigh, the taller you are. Next we have average daily temperature and number of visitors. So my line kind of to best fit that. Again, a little bit stronger than our previous example, not as strong as the first one, but it does tell me that there is a positive relationship here. The higher the average daily temperature, the more visitors to the beach. And the last one here is January temperature versus latitude. So this is the one example we have that is a negative relationship. It tells me as I increase my latitude, so that's the farther you get away from the equator, the lower your January temperature, which makes sense. You're colder the farther you are away from the equator. So this is a pretty strong relationship, it looks like, but it is negative. So we kind of already talked about things you notice from each graph. You know, you can determine a general idea of the strength. So you can get a general idea of strength. So you can kind of guess, okay, this is strong, this is weak, but you can definitely figure out the direction. So you don't have to have the correlation coefficient to determine direction. It is something you can determine by kind of guesstimating your line of best fit or just looking at your data. Okay. So now we're going to talk about how we are going to calculate our line of best fit and correlation coefficient. So we are going to be using Desmos. So the steps here for Desmos is you're going to go to the Desmos graphing calculator and you're actually going to create a table. So the little plus button in the top left, you're going to click it and then you'll select table. And then you're gonna go ahead and insert your table of your data. Then on a new line, you're going to type the equation y1 and then the approximate symbol ax1 plus b. You don't have to do anything special to get that subscript. You literally just type y and then 1 and it automatically makes it a subscript. So once you put that on a new line, it will automatically give you the equation. So you're going to see the letter A, that's our slope. The letter B is our y-intercept, and then the letter R is our correlation coefficient. So if you want to go ahead and pause here real quick and go to Desmos and go ahead and add the table for our example here, and just to make sure you can follow along and you're getting the exact same things as I did. So what we have here is a table of data for animals, their average brain weight in grams, and their max life in years. So we're going to calculate the line of best fit. We'll also find our correlation coefficient and discuss its strength and direction. So first thing I need to do is figure out which is my x variable and which is my y. So my brain weight is going to be my x, and my max life is going to be my y. So when I'm putting in my table, I'm going to put brain weight into x and the max life into y. And then I'm going to type the y1 approximately ax1 plus b. And I'm going to look under where it says parameters. And that's where I'm going to find a and b. So the way I'm going to write my equation is I'm going to do y1 and then I'm going to do my approximate. I'm going to plug in my a value. In this case, I'm going to go 3 decimal places just because it's so small. So I'm going to get 0.097 and then x1 plus my b value, which in this case is 5.432. So that is the linear equation that best fits this data. You can also see as you were creating that table, it was plotting the points. And if you zoom out a little bit on your graph, because we do get some pretty large values, you can actually see the scatter plot. And once you finish typing that equation, it actually draws the line that fits the data. Next, we're gonna get our R value, which if you look under where it says statistics, there's something said R squared, which we are not gonna be discussing. Then there's something called R, and that's what we want because that's our correlation coefficient. So our R value is 0.9756. So when it talks about correlation coefficient, how do you know whether or not something is strong or weak and whatnot? Correlation coefficient is always a number between -1 and 1. So just something to add here, R is always between -1 and 1. So then depending on whether or not R is positive or negative, the closer it is to 1 or -1, the stronger the relationship there is. So in this case, I have 0.9756. That's pretty close to +1. So this is going to be strong. That's going to be my strength. And for my direction, is it a positive number or a negative number? And R is positive here, so it's positive. You can also see by the equation and your scatter plot, it is a positive relationship. So let me know if you have any questions about how to create the table in Desmos, type in the equation, identify R. Just let me know if you have any questions about lines of best fit.